Okay, so today I'm going to show you a demonstrator lab. It's for 122. It's called Special Photometric Determination of an Equilibrium Constant. So we began to talk about equilibrium a couple weeks ago, and now we're going to apply it to an actual experiment. There's two parts of this, so I'll tell you the objectives. So number one, we're going to learn how an equilibrium constant can be measured experimentally, perform equilibrium calculations involving changes in concentration as the system reaches equilibrium. So this is like an ice table. You're going to see how I use the spectral photometer again, like in the introspectral lab. And basically you can see me do some more dilutions like I did with the introspect. So I'll send you out the lab that has to do with this. You'll see the chemical reaction, but basically what it is, you take iron. Let's see if we can get it over here. Okay, so you take iron, and then you're adding it to thiocyanate, and then it forms iron thiocyanate 2+. And then that goes in equilibrium. Sorry for the shakiness, but that's holding it. Right, and then you can see underneath it is the equilibrium expression. Okay, so what we're going to do, first thing I do is I'm going to make up some solutions and then figure out a standard curve because we're using a spectrophotometer. So what we're going to do is we're going to vary, the experiment will be looking at differences in absorbance. And the reason why we do that is that we can measure concentration by measuring the differences in absorbance. And using Beer's law, which we talked about in intro spec lab, we can come up with the relationship between concentration and absorbance. And once we do that, we do the experiment, we measure absorbance, and then if we know absorbance, we can figure out calculations. Concentration. So, so this first video is I'm gonna make the calibration curve. Okay. Okay. So there are three. I'm going to make 5. Okay, I'm going to be making 5 solutions: 1A, 2A, 3A, 4A, 5A. What they have in them is they have iron nitrate. Okay, 0.2250 molar. All of them have the same amount, so there'll be 20 mils in each one of these. These are 100 mils of volumetric flask. So what I'll do is I'll add 20 mils of the iron nitrate to each one of these, and then each one of them have a different amount of the thiocyanate. So in one I'll have 0, 2, 4, 6, and 8. So let's get going on that. So if you see the way I have it set up here, this guy here is what I'm going to be filling. After I add the two substances, I'm going to use 0.1 molar nitric acid instead of water to bring them up to their final volume. I don't want to use this big jug, so what I did is I put some in a beaker so I can transfer it. Okay, I'm going to be transferring the iron nitrate using a 25 mil volume graduated cylinder, and to get the ammonium thiocyanate, I will be using a 10 ml pipette. Okay, so let's get started. I should have a funnel to help us out. Okay, where is that? Okay, there's no particular order. I'll put in a thiocyanate in it. Right, and okay, so what I'm going to do is use a pipette and help me get it to as close as I can, and exactly to 20. Okay. I'm going to rinse a little bit with my nitric acid. Okay, so I'm going to do that with each one. Okay, and rinse it out. Gotta be careful. This funnel is top heavy, and so it can tip things over if you're not careful what you're doing here. Okay, so and like I didn't want to use the big container of the iron nitrate, so I moved it to a 125 ml Erlenmeyer flask, so it's easier to work with. So when you do this rinsing and etc., this is called being quantitative with your work, okay? And is you want to be as precise as you can, and there's always better ways, more and more ways to be precise. One would be use a better measuring device than a graduated cylinder. But I've decided to use this. So again, I get it up about 19. Get the rest of it up to 20. This graduated cylinder goes to the 10th. So really good at measuring. Now, in this guy, I added more than, so I need a total of 100. I put in about just over 100 into the Erlenmeyer flask. Oops, okay, I had too much. Okay, it's at the meniscus. What I want, I'm going to put this over by the, it's stock solution. Rinse it out. Okay. Alright, so each one of them has 20 mils, hopefully 20.0. Okay, so on the iron nitrate. Okay, next thing I'll do is add different amounts. So this guy gets nothing, so I'm put it aside. This one will get 2 mils, 4 mils, 6 mils, and 8 mils. And I'm going to use a 10 mil pipette. Here's my ammonium thiocyanate. So first one gets 2. So okay, it's not doing what it's supposed to, and I think it has to because it's not on there good enough. Maybe have to get another one. Yeah, let me go get another one. The pipette pump seems to be leaky, so big red one here. Okay, so on the pipette, it has 2 ways of measure. So if you want to let out a certain amount, you raise it up to 0 and so forth. So I just want to have 2 mils, so I can measure up to the 2 mil mark here. I'm going to measure up to 8, all right? And then I know that this whole pipette goes for 10, and so if I measure up to 8, I'll get the 10. Now, if you notice, doesn't have any 10 down here. So what you have to do is you let all of it out, and then it's measured, so you don't have to like knock all of it over. You just have to get that last drop off. So. So I get 2 mils. All right. Now there's a tiny bit left. I don't have to worry about because it's already working. That accommodates for that difference. Okay, next one gets 4, so I go up to 6. And I just kind of put it on the side. If there's a little drop at the end, I kind of knock it off. Anything that gets on the side, I'll worry about that when I fill it up to its final volume. Okay, so that's 4. Now I'm going to go up to 6 mils, which is 4 on this. That's 10 minus 4 is 6. Okay, and then this one is 8, so I go up to 2, which is 10 minus 2 is 8. Okay, now I'm done with the cyanide. I'm going to set the pipette because I think I'm going to have to use it for the next experiment. All right. Okay, now to each one of them I have to raise them up to 100 mils. Now, if we take a look at them, okay, you can see that there's, maybe you can see the differences. There seems to be a change in the color as you go up. There's less and then darker down here. Okay, now what we're going to do is add the nitric acid. Add to each one up to 100 mils. So I'm going to rinse out my funnel first. Rinse it out with tap water. And then rinse it out with distilled water. I'm going to wipe off the inside and the outside a little bit. Okay. Whoa. All right. So make sure you label things, okay? Because if you don't label, you're more likely to forget what you're doing. So the line for this one is about here. I'm not going to fill it all the way up. Again, I'm going to just fill it to where the neck begins, and then I'll pipe in the rest. Make sure you're careful with this, because if you mess up, you gotta start over with a particular sample. Okay. And believe me, I've done enough of these and messed up enough that I don't like messing up. Number one. Now, okay. I'd like to know what I just did with those caps. There they are. I want to mix them up. Number one done. Okay. Okay, number two. Same thing. So let's be careful, because if I fill up here and watch what's happening down here, you got to make sure whatever's here goes into here, because if you and then you got to be careful that it doesn't shoot up, all right? Because once it gets to the neck, it'll shoot up really fast. Right, number two. Okay, when I look at number one, number two looks a little bit more cloudy. Okay, I'm going to add more of my nitric acid. To my beaker. Okay, well, I'm showing you this. I mean, I can turn off the video and go to the next step. I want to show you how careful you got to be when you do this. And, you know, one thing about chemistry is it takes time, right? You have to be patient with making your solutions. Because if you just take your time and do what you need to do to get set up, you won't possibly, well, it's always good to do the experiment more than once, but what I mean by doing more than once is doing it right more than once, okay? So you don't want to do an experiment, 30 times because you messed up. Okay. So far, so good. Okay. Okay. You just want to do the neck with this transfer pipette. Okay. Again, get the meniscus just under the line. Okay, one more. Okay. All right. Here's my 5 solutions. And so let's take a look at them and see. If you look at them, you can hopefully you can see that from the left to right it's more cloudy. Okay, and that's because they have different concentrations. Okay. All right, next thing I'm going to do is I'm going to come over here and I'm going to do use a spectrophotometer like I did last week, or use the intro experiment. And this is basically a Beer's Law, so I'm using my phone, which has got the app. And I bring my samples over. Okay. Okay, so 1, 2, 3, 4, 5. Okay, so there you are, and there they are. So I'm gonna use a transfer pipette. And I can use the same one. Okay, because I'm going to start with the least concentrated and move to the most concentrated. so so I'm connecting my phone through Bluetooth. Hopefully, okay, it's connect. Okay. Right, it says it's connected, and what I'm going to do, I'm going to pick Beer's law. Okay. And that's going to plot concentration versus absorbance. I mean absorbance versus concentration. Okay, it's setting up the calibration. I'm going to use 1A as my blank because it has no, it doesn't have both of the reactants in it. So I have five cuvettes, and I'm going to use this cuvette for the first one. I'm just going to pipe that out enough to fill in the cuvette. Okay. And then put it in the spec and get the reading. Okay. So okay, it says put in the blank. So I'm going to put the blank in and finish calibration, and I'll be telling you the values. So this first one has a well, the concentration is going to be 0 of the thiocyanate. Okay. All right, so the wavelength that we're going to be using is 447. So I put that into my phone. I don't want to pick it up because I might push something. So so it has an initial absorbance of 0.015. Okay, so I'm going to set that aside. Okay, now I'm going to go to number 2. Okay, I'll stir this up a little better. All right, number 2 has an absorbance of 0.040. Whoops, what are you doing? Okay, now it's changed. I don't like that. So I'm gonna redo this one. Okay, so now it said 0.02. So I'm gonna get another sample in there. Make sure all the bubbles are not in there, okay? Put it in the right way. There's an arrow on the spectrophotometer. You want the clear side going to the spec. Okay, now it says 0.028. I'm not convinced yet. I'm going to take it out and put it back in. Okay, and it's 0.0. So number 2A is 0.022. Number 3, so they've gone up. It's always good to wipe off the sides. So number 3, hopefully it'll go up. Okay, it's gone up. It says 0.027, but I'm gonna